Alright, let's talk about children processes. In this problem, we are given two arrays, the PID and the PPID. If you don't know what is PID and PPID, it's actually the process ID and the parent process ID. In Unix, we have PS command list or the PID and PPIDs, for example. This ID, process with ID 0, is a parent of process with ID 1. That means when Unix started its first spawn, a process with ID 0, this process started this process, and this process started a lot of other processes. So it's a parent of a lot of the other processes. And if we keep going, okay, you see there's a lot of processes started by process 1. And here this process with ID 80 started this process. If we keep going down, we should see more processes started by process with ID 1. This is how the Unix get organized. Okay, here it's get more interesting. This process started many children processes, as you can see. And okay, that's it. When we rolling down, we can see there's a lot of processes. Okay, we are now reached the end. And that's a short introduction about what is a PID, PPID. So for example, giving us an ID, process ID 7. This process ID 7 is a parent of another process, which is 5. 7 is also the parent process of 2. So this process started process with ID 2 and 5. Alright. And process 5 is not in this list. That means process 5 don't have any children. Process 2 in this list have a children 1. So 1 then don't have any 1 is not in this PPID element. 1 don't have children. So given 7, by looking at those two arrays, we can figure out 7 is a parent of ID 5, 2, and 1. This is the output we want to give. And how we solve this problem? The first impression is this is a graph traversal problem. Given those two arrays, we can find the adjacency list of any of those nodes in the PPID. For example, 7 have adjacency node 2 and 5, and 2 have adjacency node 1, right? And the same, 9 have adjacency node 4, 10, and 6. So if we can iterate through those two arrays, we can build the adjacency list. And one thing to notice is this is a digraph because we want to go from the parent to children. We don't want go from children back to parent. So this is a digraph. Once we have that digraph, we can use a DFS or BFS. Then we traversal from the starting point. Find as many nodes as we can reach from this starting point, and then we are done. Or the node reachable is the children nodes. Okay, and let's take a look at the code. First of all, we are given those PID, PPID. We want to build the graph first. Once we have that graph and we have the given starting point, we can use the BFS traversal, and finally BFS traversal will tell us all the nodes reachable from this starting point. Let's see how we build this digraph. In order to build a digraph, we need a hash map. That's basically what the graph is a node and adjacency list. And we get the length of PID. PPID also works because those two arrays have the same length. And we iterate through. We find the parent-children pairs. And for each parent node, right, we create an adjacency list. If this adjacency list already exists, okay, we add the children to the existing adjacency list. If that adjacency list doesn't exist, we create it, then we add the children into that adjacency list. Finally, we return this digraph. Now we have this digraph, right? We have this digraph. Next thing we do the BFS. The BFS is quite standard. Nothing special here. We first create a set to mark all the nodes we visited, and we have a queue. We push the first element, we mark the first element as visited, we push the first element into the queue. As long as the queue is not empty, we get the element from the top of the queue. And this line is because, for example, we reach this node don't have any adjacency nodes, and we just continue. We skip that node. If there's any adjacency nodes, then we iterate through all those adjacency nodes. If we haven't visited, then we mark it and we visit it. We put it into the queue, so in the next while loop we can visit it. At the end, all the nodes we visited belong to the subtree, rooted as a starting point. So this is a solution of this problem. In order to build this graph, we need to visit all the nodes in the PID, PPID. So the time complexity is O(n). Space complexity is O(n) because the graph need to have the n nodes, and at least n nodes, right? And the queue size will not be bigger than n. So our space is bounded by O(n). This is a PID, PPID problem.